are going to start the class. Others can join, okay? Right. Today, you can check your LMS. I uploaded all answers for time value of money as well as valuation what we have done. So you can please check the answers and etc. with the exercises, send it to you. So I move to today's other topic called risk and return. So connecting with the valuation and this topic, after that I can explain the assignment, group assignment, but you need to take it up. So moving to this topic, risk and return. So this is what we discussed with earlier in the introduction class. Every decisions, financial managers considering all decisions always involves with risk, while company try to always maximize the return via wealth maximization. This is what fundamentally we have a basic idea what we learned when we discuss about our topic finance or financial management. So what is this risk return trade-off? What is this relationship? How it can be measured? Those are the discussions today. Basically, we are going to discuss about this risk and return topic. Moving to talk about the risk actually. As I said, it's the fundamental concept. How we can make decisions for finance, we are making always future decisions. Since we always forecasting future cash flows for either related with our investment or financing, etc. So due to that, so taking this future dividend, Sandharuban, you want to ask anything from me? Right. So so here you can see, we need to see what you call this risk. How we can define the term risk. And quantifying, measuring risk, how to connect it with our financial resource allocation, decision making in any businesses. So when we considering this part, actually, this risk is connected based on what we can measurements and all. We consider based on either single asset, single investments, or lump sum funds. How these risk measurements are there? Normally, companies are doing either anyone have more than investments, assets, financial assets. They can have a group of assets, collection of assets. So in that case, how they can make decisions. So if you have anything, you can put it under the chat box. Any clarification, anything. So based on these two bases, I will discuss today's discussion in case of single assets or single investments, or in case of group of assets. Group always we referred in financial terms, portfolio of assets, companies' portfolios. Normally, companies have their portfolios. So there's no single investment by the company. Company always maximize their returns by creating portfolios. So accordingly, if you take risk return measurements and the relationship for single asset and the group of assets. So what is risk, what is return? One by one we can go. So when considering this risk and return. First, if we define the term return, right, you might already familiar to this term. It can be profitability, or it can be return, or it can be income, or it can be already be done yield from the bonds, or revenues from the sales. So here we take normally the word return, that is normally refers to the investment on financial asset is called as return. So return, how return can be measured actually. Return is received from the investments. That can be measured by basically we consider here the shareholders return. So shareholders return is they are investing on the equity capital. So for their equity investment they are receiving dividends. So T stand for current period. What is the dividend? Current year they are receiving, plus any price changes. This is called capital gain. So capital gain is for the previous year price, move from compared to this year price can be increased or price can be decreased. So what is the change on this price? So these two are normally we can consider dividend income plus this capital gain income based on the proportion of the previous year price or beginning price actually. From that, how much of return is there? So that is in percentage if we say that we can define basically as return. So return is tan basically these two terms. So if you take what I explained this concept, dividend plus capital gain, so we can consider that based on this example. You can see here, this is a particular company, Apple stock, trading for 90 rupees 75 cents per share. Other company, Walmart, valued for 55 rupees 0.33 cents during the year. This company, Apple company, paid no dividends. Walmart received dividends of 1.09 per share. But what happened at the end of the year? Apple stock was worth for 210.73. Walmart stock come down the price with 52.84. So here we can see Apple company not paid dividends, but price changes we can see greater price changes. Beginning price 90.75. So end of the price. This is price at T time. This is price at T time. 90.75 is the price at T minus 1. Previous price. This is the current price. So differences we consider in finance as capital gain. Price changes on the stocks, asset price changes, financial asset price changes, we refer as capital gain. So divided by the previous price, it becomes this much of percentage of return increase. So other company even dividend paid, but there is a small decline on the price. So it comes to 52.84. So you can see that drops bring the negative return. So return means return can be positive return can be negative return. Right? We usually use the word return. Either it can be positive or negative. So if you have a profit or if you have a loss, on the other hand, we can say the terms you might experience with your investment, profits or losses. So basically, if we take the same definition for the concept on return measurement, basic measurement this is. So accordingly, this I put one example here. The stock price of the stock $10 1 year before. Currently rating 9.5 per share. Shareholders just received, so currently received $1 from the investment. So what is this price changes we can consider? we can consider these price changes and we can calculate it what we have done as a return percentage. So return for this particular stock is equal to $1. Actually, $1 is the dividend. So plus price changes $950 minus $10. That is the loss, capital loss we can say, not the gain here. So this entire things should be divided by previous price, that is 10. So now you can find it out what is the return percentage for this example. So if you find the return percentage, it become positive return 5%. If you calculate for this example. So it's basically, this formula is used in all evaluation on return part. So in your assignment also, you need to calculate the excess returns of maybe stocks on the companies. So you can use this, what is the price changes. You need to consider the price changes as your excess return. Right. So moving from that, actually, if we go for, continue to discuss about this, calculation of this expected returns. Since expected return is, we need to predict. So expected means it connecting with the future. So things are connected with the future. If it is, we can go with the what you call forecasting tools. So how we can decide the expected return of investments? This expected returns or expected values, that is similar to average value. But what you learn in statistics classes in the average returns, that is from the past returns over the time you take the average. Here we are not considering the past return. We are considering the expected return as average return for the future return of the investment. Future time period, how much of return particular investment can generate. That is called this expected return. So how we can forecast this expected return? So this prediction possible through, normally we use the probability theories. So there are quantitative ways to measure the future. Then if the predictions possible based on probability, that probability theory bring from the past data to take the probability, decide the probability to predict the future, right? So company A stock returns, already last 10-year return is available. So then based on that past data, company can have a prediction, right? So if that prediction, how come? Probabilities are derived from the past data. We cannot put the probability 25%, 30%, 50% without any logic. How we decide that amount or the probability possibilities? The possibilities for probabilities are derived based on the past data. In some cases, doing this possible probabilities are not possible if the past data is there. Then what company can do? In that cases, company can go for experts' opinions, collecting the expert views and expert opinions, and then they can formulate what would be the possible probability. So this is basically connecting with probability. We will discuss on probability further on this after discussing this. So here you can see what is the equation given for expected return calculation. This is used as R bar, or you can use it as expected like this, ER. expected return, right? You can use it either E within bracket R. That is also commonly we are using expected return, or you can use it as R bar. Since you know why ER is more clear than maybe R bar, you use this R bar as average return calculation on the statistic classes based on your past data, right? So here this is stand for expected return. So in that case, this expected return, so you can see how we can calculate the expected return for the particular investment or assets. That is summation of particular return possibilities multiplied by probabilities. So it means R bar or ER is the expected return of the asset. This Ri is the possibility of the expected return from that asset. So Pi is the probability of that return occurring. So here we adopted the probability concept based on the this multiplication on this possible return with the probability is expected. Summation of all possible outcomes, that is from number starting from 1 to whatever the number of possibilities, that is up to n number of possibilities, that summation we defined as a expected return. So how we can quantify this expected return in finance? This is what the way to measure expected return in finance. If I apply this equation and see the expected return calculation, I take the example here, you can see this example. According to this example, there are two assets, asset A and asset B. So we predict based on the economic situations. So if companies normally see the possible future prediction, how economic conditions exist, what would be the expectation on the economic conditions. So here we grouped into basically three scenarios are possible. There's opportunity for the three scenarios. One is pessimistic, other one is most likely, other one is optimistic situations. So pessimistic situation is rather than current situation, the situation has gone for burst. Most likely current situation and the future would be similar. Optimistic, there's a progress or positive improvement in the future. So there are three possible ways. So what would be these possible outcomes are connected? That is measured through probability. 25% chance, pessimistic. Most likely 50%, optimistic 25% chance. Due to that, you can see the return on this asset A and asset B, how it changes. In the pessimistic, return on asset A is 13% return, right? So actually all these things are in percentage 15, 13, 17. Or otherwise, for how we need to write? We need to write at 0.13. Right? You have to put it on the percentage or you can put it as 0.13. Right? So here in case of asset B's return in the pessimistic situation, only 7%. Similar situation, most likely same, both generate 15%. But here in the positive situation, optimistic time, asset A, you can predict 17% return. In case of asset B, it goes to very higher return, 23. So you can see even two results. But the situation, based on the situations and the probability expectation, you can see the returns in the pessimistic and optimistic situations is, asset B exposed to goes up and down in the variation is high in the return. So this asset A influence on these situations are less compared to B, right? That is 13 and 17. So now we come to our expected values of return on the assets and assets A and B. How we can calculate? We use the previous equation, Ri multiplied by B, Pi, summation of all the possibilities. So that is what I have done. First I take each possibility and multiply it by Ri into Pi. So if we say take 13 percentage directly, it comes as you can write here what I try to explain. Say here it is I put in percentage. Then how it can shows it can be right 13 into 0.25 actually 3.2. But if you multiply it by 0.25 by 0.13, right? So if you calculate without percentage 0.13 into 0.25, so what is the answer? It can be 0.325. 0.325 must be 0 here, right? 0.0325. You understand the difference, right? This is 3.25 into 0.13. 0.25 into 0.13, yes, 0.0325, okay? So here I put it, you can see 3.2 should be connecting with the 5 also. Right. So you can see there, if you but if you consider all here percentages, you need to use the percentage, okay? Right, I use it as percentage. That is what you can see. This is also comes as a, then you need to use it as a percentage, right? Otherwise, you need to use it multiplication time this way. 0.25, 0.13, you need to write this. So adding these all, actually that is what the equation, multiplication, after that summation. So summation of all these possibilities, it becomes finally this 15 percentage. So we calculated the expected returns for this asset A and asset B, as I show here in the example, the way you need to calculate the expected return. From the expected return calculation, we can move to the other concept called risk. So here we are going to discuss about risk measurements. Right. I think you might experience with the risk. You heard about risk. Normally, Dilini, what is risk? Since even you are not learning finance, you talked as a risk always. What you talked as a risk? Madhushani, what is we known as a risk? Why we our maybe in layman even talked about risk, what they feel as risk actually. What is called this risk?
Uncertainty regarding future.
Sorry?
Uncertainty regarding future.
Okay, yes. So considering this risk actually, normally we see without considering, very specific definition in terms of finance. We see this risk as some kind of negative outcomes, right? But it would be in day-to-day life, we feel it as some negative things are risk. But actually in finance, not only negative, it considers even company have a positive. Risk can be either negative outcome or positive outcome, all are considering as risk in case of finance terms. This risk is kind of, it's a psychological value. or we can say psychological connecting concept. So accordingly, so we can define this term risk in basically based on this finance concept as I explained, both positive and negative outcomes. This is actually uncertainty surrounding the returns. In financial definition for risk, how much uncertainty surrounding the returns are called risk around the investment, whatever the investment, or stocks or bonds or mutual funds or businesses or whatever. So on, the returns are how much of uncertainty to receive that returns in the future. If we have 100% we can receive, then that return is risk-free return. That is, normally we use the word, there is no risk, that is risk-free. We'll discuss later that risk-free return. But all the investment except the situation, so most of the time, 99% of the investment have a risk uncertainty, and not in the future make sure 100% we can receive. So uncertainty is around. So that uncertainty of return measurement is called risk. That is what we need to quantify. So how we can quantify these returns or risk for single asset or portfolio of asset? We will take first in case of single assets, how we can measure the risk. So risk can be measured normally by connecting with the probability theories, as I explained, the probability theory. So how this uncertainty of a single asset can be measured? You need to have apply the probability. So these probability theories are connected with the distributions, right? You learn this distribution of outcomes, possibilities in the statistics class, different distribution. Maybe normal distribution, right? Normal distribution, chi-square distribution, chi-square distribution. So you learn based on this type of data's spread, the distribution curves are differently appearing. The tails and all are differently appearing. Right? You learned under statistics class. Now application is here under this risk measurement, risk return topic. So we take here our discussion actually. This distribution of this our stock returns or investment return, financial returns are normally distributed. We have an assumption that based on the probability base, right? Probability is normally, as you know, is the chance for the outcome. So that all the chance, possibilities and the outcomes are shown in the probability distribution curves. So we assume all these finance related, investment related returns are continuous probability distribution. That is, you know now. What is the meaning of that? Right? So if I show that graph, you can simply understand already you learned. Right? So you might experience with that graph. So I didn't take it that graph here. So normal distribution curve. Right? You know what is that normal distribution curve? And based on the normal distribution curve, there is a what you call two tails. That two tails are moving towards 1 standard, 2 standard, 3 standard deviation. There are positive one side, right side you have a positive outcomes, and the left sides you have a negative outcomes, and you draw the center line as a expected outcome, expected return or average normally. That is, you used it under the normal distribution curve. Okay, so you can imagine that normal distribution curve, That is what applicable to understand our concept. So based on this normal distribution curve, we measure this. Actually, we assume our returns are normally distributed. In that case, we can measure the risk based on this normally distributed outcomes. How that measurement is possible then for single asset? So that measurement is connecting with the risk is uncertainty of returns. That uncertainties of returns are there, then risk is exists. Your return is difference from the actual or expected return. That is what risk can be measured on other term, the difference between the expected return to actual return. So actual return minus your expected return right? So you can see I typed it in the chat box. That is also risk. How much of differences exist between actually what you received, already what you expected. Why that differences happen due to the risk, uncertainty. That is also actually risk. So that is what we measured here. We are measuring how much of uncertainty or difference between this expected to actual. Why that differences we refer as variabilities. How much of variation on your returns surrounding from the investment from the average. Normally we are using arithmetic average, geometric average. So that is what we fixed as here as a expected value. Calculate as average. So from that expected value, the dots, you learn the dots in the statistics class, that each dots from the expected value, how much of difference, how much of distance it is there. If it is closer to expected value, risk is low. The distance goes further and further for the plots or points, then you can say the deviation, difference, distance is longer, then there is a more risk, high risk. That measuring that variation is known as risk. So what is the measurement then for risk is variance and standard deviation. You already heard about these two words in the statistics class. So what is variance, what is standard deviation, you studied there. Here I explained with the investment return, finance returns. So variance, how we can measure it always. We take all the possibilities. What is the difference of expected to actual return? Right? Taking all summation, that is variance. So the square root of that variance is the standard deviation. So this is the common statistical tool, standard deviation, to measure the risk single asset. That shows the dispersions of returns, dispersion of the variabilities of the expected values, how much that dispersed. That is either positive side or negative side, either positive returns or negative returns. That is what you can imagine with that curve what you learn in the statistic class. 1 standard deviation, 2 standard deviation, 3 standard deviation, right? So you learn 1%, 1 standard deviation, 5%, we learned as 2 standard deviation. Then you go with that, that is what you take the statistical significance at 95%, 99, 95 and 68, 3 standard deviation. So 95% we accommodate all the things, right? Significant level is 95. That is what that you understand what deviation, what I am explaining. Statistically, we always taking 95% confidence level. Right, here this standard deviation is the square root since we have either positive or negative returns. So we square root of those variance, then that become everything become in the positive terms. That is what you can say, square root of the variance is the standard deviation. So we can say if high standard deviations for single asset, shows high risk. If a lower standard deviation for the asset show lower risk. So that is what risk is connected with the concept of standard deviation. The measurement of risk with the returns are connected in two ways. One is calculating this standard deviation for returns. Returns can be known with certainty. There is a possibility. Returns are not known with certainty. So, in our investment or financial assets, their returns are normally the second. Returns are not known with certainty. However, there is a possibility to returns are known with certainty. In that situations, how we can calculate the standard deviation. This first part actually you learn in the statistics class maybe or as well, right? Standard deviation of population, standard deviation of sample. Mainly we are discussing about the second part. Anyhow, we refreshed with the first part. In case of returns are no, then what is this deviation from this calculation of standard deviation? So here you can see, in case of returns no, we take the population standard deviation by calculating the R bar, average, return, expected value, or R bar. Each possibility is R1, first possibility, second possibility, up to n possibilities. Take the differences to the power 2. Summation of all, you can divide it by this n. This is capital N stand for population. That is already you learned under statistics class. I just refined here. So this is sigma, this power 2 is the variance sign. So standard deviation is, this is the sign for standard deviation. So variance, square root of this variance is the standard deviation. So in case of sample, why we are always considering the sample? Since sometimes population is not known, sometimes population is very high. We cannot study entire population most of the time. If you want to study that time and the cost is involving with that is heavily, we need to devote for that. So we take the representation of the sample to represent the population. That is you learn from the statistics, sampling tools or sampling techniques. Then we can take the sample. So if you consider the sample, then similar to this equation is there. Only difference you can see, we use it for sample. Here is 2 is power 2. Only difference you can see, degree of freedom here divided by n minus 1. In case of sample, you need to go with population n minus 1. Okay. So here, now we can understand what is this standard deviation, variance and standard deviation for population and sample. This equation actually you already learned, right? I revise it in case of known situation. Returns are known. So in that cases, how to find the what do you call risk? So here I consider the following returns in percentages, all are given in percentage. For sample, these are samples, not with the population returns of the ABX company. 9%, 2%, 5%, 4%, 12% and 7%. So question is, what is the standard deviation of returns? So in order to do that, what you need to do? You need to calculate what is the expected return, what is the sample variance. Then you can take the standard deviation for this return. Right? So how you can do that? Hopefully you know this, how to calculate this. So how to do this? Already you learned, right? Say if we consider this, actually go for valuation on the expected return, We are not using. Right. Expected return is what we need to do. We need to adding all these sample returns 9 percentage. Say this is given as 9 percentage plus 2 percentage. You can add all, right? How you can calculate? Plus 5 percentage plus 12 percentage plus last 7 percentage. What we need to do, divided by how many sample is given for you? 1, 2, 3, 4, 5, 6 sample. Okay. Then what is the average return or expected return? So if you have summation on these things, it becomes 39, right? 39 divided by 6, 6.5 percentage. This is our expected return. If you want to go for sample variance, so you need to calculate the variance here. So how to calculate the variance actually, right? So we can go for 9 first, 9 R minus, this is the equation, right? R1 minus average power 2. So if you use it here, so this is 9 percentage minus 6.5 power 2. Then power 2. Power 2. Right? You need to have a summation of everything. Then plus. Then you need to go for the second sample. Can you try yourselves and update the answer for variance? Now this is 6.5. I calculated as a expected return or average return. Now you can calculate the sample variance and standard deviation. Can you try? What is the sample variance and sample standard deviation? Update the answers in the chat box after doing yourself. You can use this given equation, right? This is the equation for variance. Adding all these things, n minus 1 is the variance. Variance 13.1. Standard deviation 3 point. Okay, 3.62. %. Right, everyone can do, right? You can do it like what I have done it here. So 2 right, 2 minus, second option 2 minus 6.5, then you have a power 2, right? power 2. Something like that. If you adding all, finally you get the answer. What is the total? It's 67.5 divided by n minus 1. N number is r minus 1, 5. Right? So that is 13.1 variance. So divided by this is the square root of this variance. This is variance. So we need to take the standard deviation. Square root of this, okay? Square root of 13.1, that is equal to 3.62%. Right, okay. Right, this is clear. Already you have learned from your statistics class as well. So I don't need to go beyond this for explanation on the known situation. We will go for the situations on finance. But we have in finance, we have situations with the unknown situations. That is the, most of the time we have that situation. So if we go with the uncertain situations, returns are not certainly knowing, how you can calculate. That is what I have given the standard deviation equation here. So you have to calculate the expected return. Rj is the expected return, expected value of the return, minus this R bar is the expected value of the return. Rj is the j's possibility of return. This is each possibility. Here I use the word j in case of not a certain situation. Earlier I used the word I. Or either you can interchangeably use to j or I. So anything you can use. So here this is the expected value of return. After calculating that, you need to take each possibility, what is the difference, deviation, variance. Then you need to take the power 2 multiplied by probabilities. All these things after multiplication, you need to take the summation of all the possibilities. That is called variance. So after variance, the square root of that variance is the standard deviation. That is what I have done for our example what we have taken on the previous set with the set A. So here you can see that example we have taken these are the possibilities returned, probabilities we considered. We calculate the expected return under that slide, 15%. Then if we take the variance is Rj or Ri minus expected return power 2 probability I. So that is what I have done it here. You can see first example. So Ri is 13%. Minus, we calculated this as 15%. So power 2 multiplied by probability 0.25. So difference is 2%. Power to 4% multiplied by 0.25, it becomes 1%. Okay. So we can we can use it with the decimals other than directly percentage, 0.12. You can go with that measurement as well. Either of the way you can do it. So here we are adding all these possibilities, that is called each possibility 1, 0, 1. So adding summation 2 is the variance. So square root of this variance become 1.41%. That is the standard deviation calculation. For returns are not certain. In case of returns are not certain, we calculated the single asset case, the risk. So this risk measurement, right? So what I have done it for this asset A. Now I have given the example. Right? Here you can calculate the expected return, standard deviation. So this is returns are uncertain. That is what I gave a probabilities. The boom situation, normal situation, recession situation. 3, state of the economy. Probabilities are 15%, 60%, 25%. In case of boom, 30% return. In case of normal situation, 15. If recession, there's no return, 0. Right? So now, what we have discussed up to now, you need to calculate what is the expected return for this example and what is the standard deviation for this example. Try yourself and update the answers. What is the standard deviation? What is the expected return? Find the answers and update in the chat box for this example. Film updated the answers. Others, please try. How to do this actually? So this is return given for you. This is probability. Right. So here what we need to normally do, right? We will take both in this time Ri, this is the data, Ri and Pi with the decimals 0.3, 0.15, 0. This is probability is 0.15, 0.6, 0.25. Right. Now I don't need this one. So this is what we considered for our analysis. So if you consider this, what we need to do, first we need to take RIPI. Okay. So what we need to do, 0.3 multiplied by 0.15. So 0.3 multiplied by 0.15, 0.045. So the second column, 0.15 multiplied by 0.6, that is 0.09. Here 0 multiplied by this, it becomes 0. So if you are adding, it becomes 13.5. Okay, if you are adding 0.135. Okay, right. So this is what the answers are updated there, you can see. Now 13.5 is the expected return. Then moving to the other part is talking about variance calculation to other things. How we can take these variance calculations? So we need to take Ri minus this expected return. Okay, expected return, Ri minus expected return power 2. You can say that should be with the power 2, power 2, power 2. Then it should be multiplied by probability, right? Multiplied by the probability. That is what the equation given for you. So here it should be multiplied by Pi. Right, if we take the first one, Ri is say 0.3 minus expected return we calculated 0.135. Then we have a power 2. That should be multiplied by probability. Okay. So that should be multiplied by probability. Probability is 0.15. Now if we calculated how much this part, right? This is what variance calculation. So you need to go with the calculator and you need to do that. 0.3 minus 0.135, right? Power 2. Then you need to multiply it by 0.15. You can see the decimals are issues here. Decimals are coming out. So it comes out with the -3 decimals. So we need to type as 0.0040837. This is what we receive the number. Okay, this is what we take as a number now for this variance part. Similarly, you can calculate for each, right? So you need to write it like this way for each. Say, the second you can see how we can write. 0 point return is 1.5 here. So probability is 0.6 here. So if you calculate it here, 0.15 minus 0.135 power 2 multiplied by 0.6, right? So it become, the top it comes as a minus 0.4. So it means 0.000135, right? So here you can see what is the outcome. So this is actually 0 here, return 0. But the outcome is there's answer. So probability is here 0.25. 0.25. So if you go for that, 0 minus 0.135 power 2 multiplied by 0.25, that becomes 0.004556. This is the answer. Okay. Now you can find the standard deviation by summation on all these things. So if you take the summation now, right, this plus 0.000135 plus 0.0040837. So it become 0.08775 for decimal we take. So now you can take the standard deviation for this. This is variance. What is the standard deviation for this? Standard deviation becomes 9.36 percentage. Either of the way you can do. Right. Right. There are students already put the answers. 9.36 percentage. Yes, correct. Right. You can convert it into percentage. 9.3. So, right. Others, what is your answers? Is it correct? Only one student update the answer. Others' answers are okay. So if you go with Herath, is it answer is okay? Malsha, answer is okay. Amasha also put the answer. Kushan, Buraj Lianage, Iresha, Savandi. Hope everyone get the idea, right? Is it clear? Okay, okay. Yes, yes. Okay, fine. Right, then I can continue. So from this we can move to right now how we can go for measurements on this coefficient of variation part here. So what is this coefficient of variation? This is related with in case of single assets. So we cannot directly calculate this, compare the asset, which one have a greater risk. So as I see asset A and asset B, right? If we calculate the standard deviation, comparing by standard deviation directly, we cannot say. As I said, higher standard deviation always indicate high risk. that is not the meaning that asset A have 3.5 and asset B have 6.5, then we can say this asset B is greater risk. We cannot conclude that. Why we cannot conclude that? Since that depends on the expected return, size of the investments. This is size of the connecting with the size of the investment, their returns are there. Then what we need to do in case of single asset comparisons, we need to go for the relative risk measurements. That is what the term called coefficient of variation. This coefficient take the relative measurement. Due to that, coefficient clearly says which investment have a high risk. So what is the meaning of that relative measure? Here you can see how we are taking that. That is actually you are comparing the risk of the asset with the differing expected returns. So this is measured actually. This is standard deviation divided by expected values of returns. So it clearly shows risk per unit of expected return. Right? It shows what is the per unit of expected return. Right? We are divided by expected return now. So what is the 1 unit of expected return? How much of risk? If asset A is 1 unit, how much of risk? Asset B is 1 unit, how much of risk? Then we can compare 1 unit of asset A, this much of risk, 1 unit of asset B, this much of risk, which one have a higher risk? That is called actually measurement for this coefficient of variation. So I take the example, you can see here. Here there are 3 investments, securities. So P, Q and R. Expected return 6, calculated standard deviation 7. So now we calculate the coefficient of variation, standard deviation divided by expected return, 7% divided by 6%, 1.17. So what do you mean by this 1.17? Shows that, so 1 unit of return of this P, investment P is 1 unit of return, have a 1.17% of risk. So the Q, investment Q's, 1 unit of investment return of investment Q shows the 1.3% of risk. Similarly, for R, 1.1. So now these values, based on this coefficient of variation values, each showing 1 unit of expected return of the each securities, then we can come to the conclusion this is have more risk comparatively, this is have less risk. Asset security Q more risk, most higher risk here, R is less risk, since coefficient of variation give a answer to us. Okay, so in case of single assets, we always need to do that way. How to calculate or compare the answers. We need to go with coefficient of variations and compare, and we need to tell which single asset comparatively have higher risk for 1 unit of returns. Right? Okay, so I actually discuss up to now the single asset risk and return. Quickly we take one exercise on this part and we will continue the rest. Right. You can see here, right. Question 1 and 2 similar, but at question 1 I have only 1 asset, at question 2 2 assets. So we will go with the question 2 first. 1 you do it at home, right? So we'll do the question 2. Here you can see stocks X, stock Y. Probabilities distribution of expected future returns. Probabilities are given and all the probabilities must be equal to 1, right? You can see here also it's equal to 1. This is negative return, both. This is other returns are given. Calculate the expected return for each stock and the standard deviation for each stock. Calculate the coefficient of variation. Which stock is less risky? Explain. This part actually we discuss. This is what up to now I have a class. So can you try this example and find the answers? I will give a time. You will take 7-8 minutes and find it out the answers and update in the chat box. Okay, there are 2 students. Update the answers. Others, please. We can check the answer. Okay. Right. There are few, I think, completed the answers. Others might you are doing the answers. So if we check the answer, right, you can check the answer with me. Right, here you can see in this example number 2. So that the change is only from the what we have see the example. This is negative returns. Minus 10%, minus 35%, all are in percentages. So here PI is given. So RIPI, so this is minus 1% of return. So this is actually for asset X or stock X. So if you are multiplying by this 2% by 0.2, 0.4 percentage, 12% into 0.4, 4.8 percentage, 20 into 0.24 percentage, 38 percentage into 0.1, 3.8 percentage. Adding everything here, you have to be careful always. This is minus return. So it should be, you need to deduct this 1%. Then it becomes your expected return 12% for StockX. So StockX, if we consider that 12% as a expected return, Then we need to find the variance and standard deviation. So first is minus 10 minus 12 percentage power 2 probability 0.1. So that variance comes as a 48.4, or you can convert it. It can be maybe 0. Value should come 0.00484 should be comes. Okay. So if you consider both are in the decimals. Similarly, you calculated and you can see the variance, total variance is become this much, and standard deviation for StockX is 12.2 percentage. Okay. Similarly, go to the Y, same, we take first the expected return, first is negative return, this is 0 return, so it becomes 0. Then we adding all, we can see it becomes total expected value of stock Y return is 14%. Then we calculate for variance and standard deviation, it becomes stock by 20.35 percentage. Hope answers are correct. There is a possibility to come for exam. I think one of this similar question already they are in one of the on-site examination. Yes. So I think X is correct. Y also correct. Okay, 20.35. Right. So now that is our first question, expected return and standard deviation calculation. Part B, coefficient of variation calculation to calculate the risk measurement, relative risk measurement. So X is 12.2 standard deviation percentage divided by 12 percentage, it becomes 1.02. So here it comes as 1.45. So comparatively, this is low. So stock X is less risky compared to stock Y. Since once we relative measure of coefficient of variations is lower to stock X. So we need to conclude the answer, which one is less risky as well. So actually, this is called actually kind of discussion up to now what we have done. Right, there are few students are following and answered already. Others, I think, get clarity through what I have discussed the answer. Okay. So this is what the single asset. We are moving to the continuation on our discussion. Anyone have any doubt up to this? If you have any doubt, you can update me. Right. Right. We will move to discuss one theoretical concept on risk. What is this risk attitude? So, as I told you, risk is a psychological value or psychological perceptions. The risk can be differ between people since individual differences exist. Individually, psychologically, people attitudes are different. So that is what risk is always psychological values are connected there. So how we can compare these risk attitudes among the people? That is called, the concept is there, theoretical concept called equivalent certainty equivalent values. So certainty equivalent amount. What do you mean by this certainty equivalent amount actually? When you have a certainty at a particular point of time, that make individual indifference between the certain amount and the amount expected to be received with the risk or expected values, that is include the risk. So that those two are indifference, that point in time, that we use the word, that point of that value is called certainty equivalent amount or values. Okay. So this certainty equivalent values can be compared with the expected values to categorize the people. So here the certainty equivalent value is there is no indifference between a certain amount and the expected values received with the risk. So in that case, you can see among the individuals how we can categorize based on this concept. We can group the people into the three different sets of people based on the risk attitudes. One group of people you can see, that is those people are always have a risk lovers or risk preferred people. If they take those people, their certainty equivalent is greater rather than the expected value. But they are ready to go for risk. That is what their certainty equivalent is higher. Then for risk indifference people, their values are equal. As explained, what is certainty equivalent, right? Particular point of time, that expected values and the equivalent certainty values are equal. For risk aversion people, they don't want to take risk due to that. Always the certainty equivalent values, the attitudes, it's lesser compared to the expected value. Then they are avoiding the risk only, they have that attitude. So when we compare these three groups or individuals, normally most of the people are risk averse. That is what we can say. How many are going for stock tradings and etc. Since that is connecting with this risk as well. So people are avoiding characters, risk averse. They want to go for bank deposits or FDs compared to stock investment. That is what we can see. Actively participate the investors, individual investors in CSEs comparatively less. Most of the people are risk averse. Right. So this risk averse and all based on this. So if I explain this three concept with a particular example, then you can get more clarity on that. So here you can see, you have the choice between the guaranteed dollar reward or the coin flip gamble of $1 lakh with a 50% chance or with a 50% chance $0 with this gamble. So expected value of this gamble is then $0 we are receiving 50%. So 0 into 50, 0. $1 into 50% probability. So expected value we learned, we calculated, we know that is $50,000. Now we go for these choices with the three different people's attitudes. So Mary's attitude requires a guaranteed $25,000 or more to call off this gamble, since Mary don't want to go for risk. So $50,000 is the certainty equivalent expected values, but Mary's certainty equivalent value is $25,000. That is what we compare here, risk aversion people. Expected compared to expected values, their certainty equivalent values are lesser. You can see here, this expected value is $50,000. The Mary go with this guaranteed amount of $25,000 without risk. He is avoiding the risk. So that we can categorize Mary as a risk averse. Then bring into the second individual, you can see Raja. Raja is just as happy to take $50,000, so take the risky gamble. So this Raja's point of view, you can see. So expected compared to expected value, he also expected the $50,000 attitude. Both are equivalent. So Raja is a risk indifference individual. Sham requires at least $52,000. So his expected equivalent value is $52,000. So he expected more compared to this expected value of $50,000. So then we can see Shyam's attitude towards this risk, he preferred the risk. That is what his certainty equivalent amount is actually $52,000. Okay, I take the simple scenario to explain the three concepts related with the risk. Right, moving to this part, we need to understand what is this risk of a portfolio. Okay, considering the risk of the portfolio, that is different from risk of the single assets. So taking risk of the portfolios, that is actually group of assets or collection of investments, that is called portfolio risk. So how we can calculate in that case expected return and risk? You need to calculate the weighted average expected return is portfolios, that is portfolios expected return. Always in the portfolio management, so financial managers' goal to maximize this portfolio's return with a given risk. So that is what we call as an efficient portfolio. Efficient portfolios generate maximum return for given risk. So accordingly, if you take a simple example to understand this portfolio's return and risk, right, this is a broader concept, broader topic. I'm not discussing very detail in this class about this. I just introduced there's a portfolio. This is a separate topic, separate subject actually, portfolio management. Under that, it's the detailed measurements are there. I introduced only. In case of portfolios, what would be the measurements, basic measurement idea to get in this class. So how you can go for expected return calculation, you need to take the assets in the portfolio, first number of assets, take the weight, proportion of the portfolio's total rupee represented by the assets J, what is the weight of the particular asset or particular investment on the portfolio. If you have 100 million, how much you allocated for asset A? 50 million, 30 million for asset B, 20 million for asset C. Then you know what is the weights or proportions allocated for overall total investment, how much allocated. That is called weight 1, weight 2, weight ABC or whatever so on. The portfolio can have assets. Each assets are different returns, so that is related with their returns. So we need to calculate what is the expected returns of the each assets, multiplying by the weight, adding all, that is the portfolio's expected return. That is what weight, expected return, right? So multiplication and get that summation is your expected return of portfolio. Here you can see there are three assets with the following returns, right? So calculate the portfolio's expected return. So how we can calculate that? So this is actually asset X, asset Y and asset Z. There are three assets are there. So if we calculate this portfolio's expected return for these assets, right? So portfolio's expected return. Expected return of portfolio. Right. So why it is portfolio? There is no single asset. There are three assets. Percentages are given. Right? This is 30% is there. This is 45%. This is 25%. So how we can calculate the expected return now? We need to take this asset X, that is have how much of weightage. Percentage of the weightage is, that is go for 0.3. 0.3 is the weight. Okay, 30% is 3. Then the expected return is 0.05. Then what we need to do? We need to multiply it by that weight multiplied by expected return. Then we need to take summation of the other asset is Y. What is the Y's return? Y is portfolio weight is 0.45 weight multiplied by return is 0.1. This is Y's weight. Then go for the other asset Z. Portfolio weight is 0.25 multiplied by the return rate is 0.15. Now you can take this summation is the expected return. If you have calculated that actually, you can see that 0.3 multiplied by 0.15, not 0.1, 0.3 multiplied by 0.05, 0.015 plus 0.45 multiplied by 0.1, 0.045 plus 0.25 multiplied by 0.15, 0.0375. So now we can find what is the answer for this. If you are adding all three, 0.045 plus 0.015, that is finally becomes 9.75%. We calculated if a particular person or a particular company portfolio is represented by this percentage of investments, expected returns for each investment is this much. What is the portfolio? That particular company's portfolio's expected return, that is 9.75%. Okay? Only thing from what we learned, now we take the weights. In case of risk measurement, this is bit different from that. This is also risk is based on what you call portfolio standard deviation. But portfolio standard deviation calculation is, there is a long equation. Right? Here I directly give the equation. This equation connected with the two assets, asset A and asset B. In case of asset A and asset B, how we can calculate this standard deviation for the portfolio is given here. Right? So this portfolio's risk are different from single asset risk. Since if you have a portfolio, you might experience with a high return from particular asset A, low return from asset B. So what is your overall risk? That should be compensated from one asset to another asset. Due to that, the risk is different. So that is what, in case of that, this portfolio's risk are connected with correlation values. See, here there is a slant P, right? This is the slant P sign. A and B, two asset, correlation coefficient between the A and B. Always this portfolio's expected returns are connected with these two. How these assets are correlated with one another, that is the matter for portfolio's risk measurement. That is what I explained here, this equation with the covariance and correlation. Right? There are two terms. You heard about these two. Covariance and correlations are similar. There are two concepts we have. These two concepts are explaining in different way the same, but we explain the relationships. Covariance is explaining measurement of how two random variables will change together. That is called covariance. So that is what you can see here. Covariance always equal to standard deviation of asset A, standard deviation of asset B, multiplied by this correlation between asset A and B. That is covariance. So if you take the subject this correlation. So covariance divided by standard deviation of asset A and standard deviation of asset B. So these are very closely related terms. What this correlation is explaining, that is another way determine how two variables are related. To measure the degree of, the two random variables relationship is explained by this correlation. Normally, we use the term correlation in statistically most of the case to see the relationship between the two random variables. Here you can see that you learn what is correlation, two random series, how it moves. So if both random series are moved positively, then we refer as positively correlated. Say example, so if we have a number of hours you study particular student and getting the outcome in the final examination. So if the study time is increased, outcome, final examination results can increase. So these are two connected positively, both are connected. That is called positive correlation. So negative correlation means the opposite way the things are moved. So if the inflation rate goes up, so then we can say return from the investments goes down, or purchase of the goods goes down, real purchase of the goods goes down. Then those two variables are negatively two series relationship exists. This is what you learned as a Pearson correlation values in the statistics class. So correlation table always explaining the relationship with the values with the positive or negative. So, but that falls that between the range maximum -1 to +1. That is what maximum possible correlation. So, if you have a perfectly correlated positively positive one, if you have strongly correlated, it can be 0.7 positive. So, if you have perfectly negatively correlated, negative one. If you have, say, moderately negatively correlated, say we can say negative 0.5. So that values are shows. Say if you have a stock A, company's returns, and investment on stock B, company's returns. So either what is the correlation between these stock returns? That is very important for measurement of this portfolio's risk. That is what you can see in this equation, the right? You know equation only that you can use it. We don't need to understand how this equation is derived. So this equation explaining weightage of the asset A power 2, standard deviation of asset A power 2. Or weight multiplied by standard deviation power 2. Both the same. This is the other second asset. Here 2 multiplied by weight A, weight B. Here we need to always multiply by correlation coefficient multiplied by standard deviation of A multiplied by standard deviation of B. Or we can replace this part, these three, as I explained here. This is equal to covariance. You can see this covariance of AB equal to these three, multiplication of these three. Okay. Now I think you have a clear idea on this correlation bring for risk measurement in case of portfolios of assets. How covariance, correlations, and what would be the final risk taken by the particular portfolios having by a person or a company depend on how that correlation of the assets decide that risk level. So that is called finally portfolios measurement. Okay, right. Hope I think what I explained, the theoretical explanation on this portfolios risk measurement is clear. Right. I take one example to explain this portfolio. I think we can take now 15 minutes break. Always we are taking break now. So I can continue after 15 minutes this portfolio's question, quantitative question. Okay, shall we go for the break 15 minutes?